Today we are going to learn how to calculate subatomic particles using information from the periodic table as well as some other atomic information shorthand. You have this in your notebook. I'm going to highlight some things that are common. Here are some different formats that we write elements and some information that we need in order to calculate subatomic particles. These are symbols and this is words. I'm going to highlight similar vocabulary. So right here, this word says mass number. If it's written in this format, the top number to the left is always the mass number. And if it's written with a word or it uses a symbol dash and a number, that number is also the mass number. These two numbers are exactly the same. The other common or repeated vocabulary word on this is the atomic number. So again, in this first symbol one, this one has the atomic number on the bottom, so it's always bottom left. And if it's on the periodic table, you also have the atomic number, and it's on the top. It's not always in the center, but it's always on the top. Usually on the periodic table, it is also labeled. Down here on the periodic table, the number that sometimes has a decimal is your atomic mass. So these three words or vocabulary, mass number, atomic number, and atomic mass, are different from each other, and we use them in order to calculate the subatomic particles. We're going to use this as well as the periodic table and some other information. I'm going to set this aside. This you also have in your notebook. So we're going to go over this really quickly. It's using those vocabulary words. I'm going to pull this up so you can see both at the same time. Here we go. Maybe. There we go. Right. Close. We're almost there. There we go. If you're trying to calculate the protons, that one isn't an actual calculation. All you need to know is the atomic number. If you are using the periodic table, again, the atomic number is on the top, sometimes in the center, sometimes to the left or to the right. If you are given a symbol that looks like A, the atomic number is right there on the bottom for you. And if you're given words, you have the name, so you can go to the periodic table and find the atomic number on the periodic table. So I'd read neon, and then I could go to the periodic table, which would look like this, and I could find the atomic number. If you're trying to figure out the number of electrons in neutral atoms, it is equal to the atomic number or equal to the number of protons. And you would find that the exact same way that we found the number of protons. Neutrons, we do have to do some subtraction. If you have neutrons and you're doing the average of all the isotopes, you round the atomic mass. The atomic mass is located on the periodic table for you, so you'd round it to a whole number. So 20.180 would round to 20, and you subtract the atomic number. If you are looking for the neutrons for a specific isotope, you take the mass number, which is either written in this format or the top number in this other format, and you again subtract the atomic number. So we're going to try some of this. You're going to need your pieces of paper as well as your periodic table. So we're going to refer to all of this stuff. This is your notebook page on the bottom of 32. First we're going to do the symbols. The symbols are located on the periodic table, so the name is right underneath, and then the symbols are in the box. If it's two letters, the first one is capital and the second one is lowercase. If it's one letter, it's always capital. So lithium is right here, Li. I'm going to put that in that box. Over here is mercury, Hg, and the names are in the bottom. Yes, at first it'll take you a little longer than me to find these things, but eventually you'll know where a lot of them are. Silicon is over here, Si. Calcium is right here, Ca. Now this says hydrogen 3. This is a single isotope right here, which it looks just like this. So the back number is just the mass number. I'm still just going to look for the name. Most people know that hydrogen right here is a capital H. We have carbon 14, same thing. We're going to just look for carbon. Carbon is capital C. The atomic number, again, is very simple to find. I have a periodic table for me, so I'm going to use this format to find the atomic number, which is going to be on the top of the periodic table. So the atomic number of lithium is right here. There's a 3 written above it, so that is the atomic number. Mercury is over here, Hg. The atomic number is 80, so that's the atomic number. Silicon, we're skipping over one. Silicon's right here. Top number is atomic number, so it's 14. Calcium 20, it says the 20 is on top, atomic number. Hydrogen, there's a 1 above it on the top, so that's the atomic number. And carbon 14, carbon is right here, the top number is the atomic number, 6. And if you forget, they give you a little map right here, so if you're taking a test, you have this available to you, 6. Alright, atomic masses. The atomic mass is found on the bottom. It is not always, but it is very often a decimal because it's the average of all the isotopes. So atomic mass is on the bottom of periodic tables, and it's usually a decimal. I'm not going to do all of these. It's very similar to the atomic mass. We'll do a couple. So you probably can't see that, so let's get a little closer and see if we can focus this so you can actually see it. There we go. So lithium, the bottom number is 6.941. Atomic mass, 6.941. Mercury, so I'll slide this over. Here's the Hg, mercury. On the bottom is the atomic mass, 200.59. So mercury, 200.59. These are usually decimals. Silicon, we'll do one more. Silicon is over here. The atomic mass is on the bottom, 28.086. Here we go, 28.086. So those are just found on the periodic table. We're going to move this back up. You can fill in the rest. You get the idea, hopefully. All right, the protons and the electrons. We're going to first look at this. Protons is the atomic number. It is the atomic number. Well, that's easy. I already have the atomic number for all of these. So I'm just going to take this because protons is the atomic number. 3, 80, 14, 20, 1, and 6. Easy. The electrons, I'm giving you the wrong piece of paper. The electrons for neutral atoms is also equal to the atomic number. Or they're neutral because the protons, which are positive, is equal to the electrons, making a neutral atom. That means for now, the electrons are going to also equal the protons. Now when we start talking about ions, this is not the case. But for right now, neutral atoms only. The last one, you have to do a little bit of math. So neutrons right here. For neutrons, when we're looking for the neutrons of elements where we're averaging all the isotopes together, we're going to round the atomic mass and subtract the atomic number. So for lithium, here's the atomic mass. I'm going to round it. So 6.941 rounds to 7, and I'm going to subtract the atomic number, 3. So my answer is 7 minus 3 is 4 neutrons. Mercury, this is also an average of the isotopes, is 200.59. So that's going to round up to 201, and I'm going to subtract 80. And it's early in the morning, so, and I want to do this quickly for you. 121, that's the number of neutrons. Silicon is 28.08, so this is going to stay 28 because it's a 0. I'm cutting off the 0, and it's less than 5. Minus 14 is equal to 14. Alright, we're going to skip over calcium. It's just like these top 3. You can do that on your own. Do make sure you fill that in for your notebook check. Now hydrogen, here it says a hydrogen 3, so that's different. This is a single isotope. I know because the 3 is at the end, isotope. And the 3 on the back is the mass number. It is the mass number. For finding neutrons for one isotope, I'm going to take the mass number, which will always be a whole number, and subtract the atomic number. This makes it super easy. I don't even have to go to the periodic table. I'm going to take the mass number, which is 3, and subtract the atomic number, which is 1, and I'm going to get 2, or 2 neutrons. Same here for carbon 14. This is also, because it's written this way, it's a single isotope. Right? All of these are averages, but this is a single isotope. And based on this chart, when you have one isotope, you take the mass number, which is the 14, and you're going to subtract the atomic number. So 14 minus 6 should be 8. All right. And that is how you calculate subatomic particles. You need to know how to use these particular vocabulary words that identify the types of subatomic particles. You need to know where they're located, and you need to use your periodic table. So there's lots of charts that you're going to refer back to on a regular basis in order to calculate subatomic particles.